Hello everyone! While waiting to find models for my mammography positioning videos, I thought I would offer you a lesson that I hope you find interesting, comparing breast MRI images with mammography, DBT and Cesm images. In order to understand MRI images, it is necessary to start with the physics of signal projection. Just a hint, more in-depth explanations are beyond the scope of this lesson. Well, in order to produce MRI images, it is necessary to immerse the patient in a static magnetic field called B0 at high strength. A second magnetic field is then sent, varying in time, in the field of radio frequency, pulsed, switched on and off, called B1. When B1 is switched off, the system returns to its original conditions through a phenomenon called relaxation, which induced the formation of an electric signal in the coil, and that is the image. The signal in MRI is determined by the variation of T1 and T2 relaxation times between one tissue and another. Since the MRI signal is composed almost exclusively by water and fat, it is the different percentage of water free or bound to large molecules and fat that causes the relaxation times to vary and thus induces different image contrast. Other aspects obviously count: the number of protons present in the studied area, for example, but for this lesson we only focus on water and fat. This is a table that explains in a very simple way which tissues are high signal or hyper-intense, or white, and which are low signal or hypo-intense, black, for T1 weighted sequences, that is to say, sequences where only the differences in T1 are emphasized and the differences in T2 are obliterated. Same for T2 weighted sequences. Interesting to compare these two tables. Some surprising here. We can therefore make a comparison between these two images. The first, T1 weighted. The muscle and fibroglandular tissue are gray, intermediate signal, while in the T2 weighted image they are black, low signal. Anatomical contrast in MRI is very high precisely because of these characteristics. And in mammography, as you know, the contrast is based on the difference between the linear attenuation coefficients, which is really poor, particularly when considering healthy glandular tissue and pathological tissue, as can be seen in this graph. If we go to see which tissues form the signal between the two modalities, well, they are the same, apart from calcium, which in MRI is only seen in particular situations. As we know, microcalcifications are very important in breast pathology. This is certainly a handicap of MRI. I'm not the first to want to make a comparison between these two modalities. The Spanish scholar points out in this interesting paper how the gland appears radio-opaque in mammography and hypo-intense in MRI. This is actually not a contradiction, since, as we know, X-ray images are the negative on anatomical reality. In MRI, moreover, not only so-called morphological sequences are acquired, but also sequences such as this one you can see in image B, called dynamic sequence, after injecting a contrast medium, see It is a 3D sequence in which the same volume is acquired, but in different phases, one after the other, the first without CM, the following afterwards. The two sequences here are both T1 weighted. The dynamic one got special fixtures actually, and the fat in the second one, the dynamic, must be suppressed. The first phase without CM is co-registered on the others acquired after CM. What is obtained is the ablation of the anatomical background, which is exactly the same in all of them. What are called subtracted slices are formed. Adding up the subtracted slices gives the MIP. Certainly, therefore, three-dimensionality in both acquisition and reconstruction MRI is a point of strength. The second one is being able to include very deep tissues, which is impossible to get even in a very well-performed mammogram. But what makes the real difference between the two is the possibility of getting functional data. What does functional mean? In MRI, the dynamic sequence images can be interrogated using specific software to produce map such as this one, called Wishing Map, in which different colors are assigned depending on the speed of enhancement of the lesion. Or this one, a time intensity curve, in which the second part evaluates how quickly the contrast medium is removed from the lesion. This is important information for the reporter and is based on the phenomenon of neoangiogenesis. Also of interest, although used less than in prostate studies, is the DIV-Y diffusion, which indicates how difficult it is for water to flow in pathological tissues compared to healthy ones. There is a multi-layers mammography, as you know, and that is DBT. This also involves the acquisition of a volume, which is then subdivided into slices, generally half to 1 mm thick, using dedicated software. Interesting methodology affected by many artifacts resulting from the type of acquisition, which is not a real three-dimensional one. However, it can forgive some positioning errors, as you can see, and can solve the summation artifacts. As far as functional information related to neoangiogenesis is concerned, there is a parallel between mammography and MRI, and it is given by Cesm or spectral mammography with the CM. In this case, in addition to acquisition with a standard anode filter combination, which produces the low energy image, here, a high energy image is acquired, not shown here. These two images, low and high energy, are co-registered and the recombined or iodinated image is obtained. It's so called because a iodinated CM is used as in CT. Here is the one. There are thousands of scientific papers in literature comparing Cesm and MRI. It is a really interesting methodology. Functional information will certainly become more and more important in the future, so MRI and MVI, the study of the breast in the nuclear medicine department, will become, I do believe it, increasingly important, thanks also to the use of artificial intelligence applied to radiomics, radiogenomics, and to the evaluation of the image quality produced by any modality. Well, I would like to ask your opinion at this point, while waiting for the videos on positioning mammography. Which of these topics would you like me to elaborate? MRI, stereotaxis, or DBT? Thank you for your attention, and see you